Hello everyone, I'm Ruifeng from North China Electrical University. And my introduction about our research with the landscape of renewable energization potential of the land transportation infrastructure assets in China. My introduction includes the following 5 sessions. First, introduce the strategic significance and implementation necessity of the integrated development of transportation and energy. As we know, faced with the severe challenges brought by the resource scarcity, climate change, and environmental pollution to mankind, the extensive non-coordinated growth mode is unsustainable. Industrial transformation and upgrading have become the main policy oriented and fundamental way for countries in the world, especially the developing countries like China. China is a big energy importer, and its transportation system is a major energy consumer. Energy and transportation are the most important basic industries of the socio-economic system and the technological field, with the characteristics of the master urgently need major changes to lead and reshape the economic development mode. Looking back at the history, the inductive development of energy and transportation has always been the basic condition and guarantee for the effective operation and continuous progress of human social and economic progress. The integrated development of the two plays an irreplaceable role in the continuous formation of a new mode for human social and economic development, new civilization. At this time, we have experienced the 4 generations of the civilization. The first generation is the agricultural civilization, and the second is the first industrial revolution, and the third is the second industrial revolution. And now is the fourth generation, the integrated development of energy and transportation that can bring new modes, new technologies, new formats, and new industries. The integrated development of transportation and new energy become a reversible trend of time, which is related to the strategic layout of the country's future development. How to build a new, green, flexible, self-consistent, and sustainable transportation energy integrated system has become an inevitable path to build a beautiful China in the new era. In the second session, I'll introduce a survey of the solar resources in China's land transportation infrastructure. First, we'll overall overview the land transportation system in China. As of the beginning of 2018, China's highways were about 136,000 kilometers, and national highway 126,000 kilometers, and provincial highways 372,000 kilometers. As of the beginning of 2018, China also had operated 29,000 kilometers of high-speed railways, over 92,000 kilometers of electrified railways, and over 41,000 kilometers of non-electrified railways. Here we have shown the distribution map of China's highway network and its railway network. In this research, we have investigated the joint distribution of China's land transportation network solar resources by estimating the amount of new energy resources owned by China's land transportation infrastructure and the total annual operating power consumption of the system. We have completed the assessment of the self-consistent rate of the energy demand for the system. In the third session, we have calculated the solar power potential of the whole system. We have calculated the highway system, national highway system, the provincial high system with a road map, and then we calculated the electrified and the non-electrified railway system respectively for the highway solar energy developing potential. According to the basic scenario, its annual power generation is about 25 billion kilowatts, and for the positive scenario, it can reach 193 billion kilowatts. These two tables and the fig have shown the typical daily solar power generation potential under the basic and the active scenario. For the national highways and provincial highways, we have estimated the conservative scenario and the active scenario respectively. For the national highway, with the conservative scenario, its installed solar capacity can reach to 6,699 million kilowatts, and the active scenario, the installed solar capacity can reach 129 million kilowatts. For the provincial highway system, the conservative scenario, it can reach 1 million kilowatts, and the active scenario is about 148 million kilowatts. The following figure have shown the typical daily solar power generation potential with the active scenario. For the high-speed railway, we have estimated its solar energy development potential. According to the calculation based on the basic scenario, it can reach about 170 billion kilowatts. And with the positive scenario, it's about 274 billion kilowatts. Also, this table and figures show the typical daily solar power potential under the basic scenario, active scenario, high-speed railway. With the non-electrified railway solar energy development potential, we have calculated the two-line laying method and the single-line laying method respectively. For the two-line method, with the basic scenario, it's about 12 billion kilowatts, and with the positive scenario, it's about 29 billion kilowatts. For the single-line method, according to the basic scenario, it's about 767 million kilowatts. And with the positive scenario, it's about 1.298 billion kilowatts. In the fourth session, I will show you our result on the energy consumption assessment. We have calculated the highway system and the railway system respectively. For the highway system, we have calculated a constructed model with the tunnels, the total station, the operating management center, then conservation center, the city center area, the living area, and the facility along with the highways. According to the calculations, the average daily power consumption of China's express highway system is about 23 million kilowatts. And its annual power consumption is 8.494 billion kilowatts. Here we show the typical daily power consumption in the four seasons of China's highway system. For the railway system, according to the calculation, we include factors like bridge, operating management center, observation center, high-speed railway station, facilities along with the highways. According to our calculation, the average daily power consumption of the whole system is about 230 million kilowatts. And its annual power consumption is about 83.94 50 billion kilowatts. Here, we also show the typical daily power consumption of the railway system in 4 seasons. Finally, in the 5th session, I will show you the assessment of the energy development potential of China's land transportation system assets. With the basic variable required for the indicator definition, we first define some parameters. First, Q1. Q1 is the real-time self-generated self-consumption power of the line. Here, the line means a road or railway system. Q2 is the total power consumption of the line on the typical day. Q2 equals Q2 apostrophe plus Q1 plus Q2 apostrophe. And Q3 is the maximum power generation capacity of the system. Q3 equal to Q1 plus Q3 apostrophe. After the parameters definition, we have defined some indices to evaluate the effectiveness of our system. First, we defined the transient self-consistent rate. This means the proportion of the line that meets the energy demand by its own infrastructure solar power generation system. It's equal to Q1 divided by Q2. And the total self-consistent rate refers to the proportion of the line's own infrastructure and solar power generation that meet energy demand. It is equal to Q3 divided by Q2. We also defined the power shift rate, the maximum power shift rate, and the new energy penetration rate, etc. For the result, the evaluation of the potential for energy conservation of highway system. For the basic scenario, the Chinese expressway highway system, the maximum transient self-consistent rate is about 62%. The maximum total self-consistent rate is about 633%. In the positive scenario, the maximum transient self-consistent rate is about 66%. The two figures show our calculation result. We evaluated the potential for energy conservation of the highway high-speed railway system. In the basic scenario, highway speed railway system, the maximum transient self-consistent rate is about 56%. The maximum total self-consistent rate is about 284%. And in the positive scenario, the maximum transient self-consistent rate is about 68%. The maximum total self-consistent rate is 3,789%. These figures show the detail of the calculation result. For the non-electrified railway system, we also investigated the basic scenario and the positive scenario respectively with the two-track or two-line laying method, the one-line laying method. This table shows the consistent rate and all the other indices. As a conclusion, for the new energy development potential of China's land transportation system, for the highway system, in the active scenario, the potential is about 725 billion kilowatts. The basic scenario potential is 56 billion kilowatts. For the railway system, the active scenario potential is about 305 billion kilowatts. The basic scenario potential is 183 billion kilowatts. The total annual development potential of the whole system is 1,030 billion kilowatts in active scenario and 240 billion kilowatts in basic scenario. the overall energy consumption of China's land transportation system. For the highway system, we didn't include the vehicle energy consumption. It's about 8.494 billion kilowatts. And for the railway system, didn't include the tracking system. It's about 88 billion kilowatts. So the total self-consistent rate of the new energy development in China's land transportation system. For the highway system, the positive scenario is about 8,537%, and the basic scenario is 670%. For the railway system, the positive scenario is 343%, and the basic scenario is 206%. And besides the technical analysis, we also investigate the profit and the investment of the model. First, for the highway system, here we only consider the high-speed highway only. The positive scenario is 131 billion yuan every year, and the basic scenario is 16 yuan every year. For the railway system, the positive scenario is 1,468 billion yuan every year, and the basic scenario is 964 billion yuan every year. For the investment cost, the highway system is with the active scenario. The investment demand is 485 billion yuan. The basic scenario is 63 billion yuan. For the railway system with the active scenario, its investment demand is 362 billion yuan. Basic scenario is 198 billion yuan. And last, I'm very glad to introduce our research team to all of you. First, the background. The name of our research team is China Institute of Energy and Transportation Integrated Development. We run unit with North China Electric Power University, and we founded by 9th June 2018. We supported by several ministries of the government. The vision of our institute is with the purpose of national decentralism, distinctive characteristics, mechanical innovation, leading development. The institute persists in promoting the integrated development of energy and transportation and the research of the new generation of these two sectors. Our mission lies in three aspects. First, constructing a novel think tank on energy and transportation integrated development with international influence to serve the national dual carbon strategy. Second, coordinating the transportation and energy technologies to contribute the socio-economic development. Third, building a policy and decision-supported platform, innovation and industrial development platform. That's all. Thanks for your listening.